We're now going to turn our attention to a wrapper class that can encapsulate the ManageBlocker interface with an easier to use object-oriented facade. And we'll demonstrate how to use this in an interesting example. So we're going to define a class, a helper class called BlockingTas. And what it's going to do is it's going to make it really easy to integrate blocking suppliers with the common fork join pool. And it uses some very clever programming techniques, which we're going to look at in more detail. You can actually find this example in the folder in my GitHub repository that's got a link at the bottom of the page. So BlockingTas is a class, and it defines a method called callinManagedBlock. And this enables the use of blocking suppliers. As you can see, the parameter that's passed here is a supplier with the common fork join pool. And if you take a look at the Stack Overflow link at the bottom of the slide, you'll get a chance to see an evaluation of the pros and cons of this particular approach. I like this approach quite a bit, but as always, there's always pros and cons you have to be aware of. So let's take a look at how the callinManagedBlock static method is defined. The first thing it does is it makes a helper variable or helper object to encapsulate the supplier. And this is called supplier ManageBlocker. And we'll take a look at that nested class here in just a second. So we're going to make ourselves a ManageBlocker variable of type supplier ManageBlocker. And that's going to encapsulate the supplier parameter. And then we're going to say fork join pool dot managed block, passing in our ManageBlocker. So the nice thing about this is we no longer, as application developers, have to know or care anything about how the ManageBlocker interface is working. We are just going to pass in a supplier, and we'll let the details of this wrapper class handle all the implementation issues. So that's going to submit the ManageBlocker to the common fork join pool. And then the last thing that we're going to do here after ManageBlock returns, in other words, after we've finished the computation, we're going to get the result from the ManageBlocker object. And so that will actually get the result and return it. And that'll come back for type T, whatever the type is that we're going to be getting as a result of doing this callinManagedBlock method. So now let's turn our attention to supplier ManageBlocker, which is this nested class that implements the fork join pool ManageBlocker interface. And that allows us to use the blocking supplier with the common fork join pool. We have a field here that's called mSupplier that is going to be used to stash the parameter that's passed in. So we get a supplier, we store it in the field. We have a Boolean that keeps track if we're done or not. And then we also have something that keeps track of the result. And we're going to keep that so we can get the result after the blocking is over. Now let's take a look at the key methods. This is the method that does the most important thing. This is the block method. And what it does is it goes ahead and calls mSupplier.get. And of course, supplier is whatever you passed it in. So this call can do whatever we need. It might download a file from a remote web server. It could do the queue taking stuff that we saw before. It could do the synchronizer stuff that we saw before with the ManageBlocker implementation in the previous part of the lesson. Whatever it does its thing. We don't know, we don't really care, but we know it might block. And therefore, it's going to get the result and store it in the mResult field and then set the mDone flag to true. Is releasable just returns whether we were able to obtain the object through the get call. And notice that there is no non-blocking behavior for this particular class, which is why we don't really worry about exposing the isReleasable method. And then finally, we have another accessor method called getResult, which will return the result, which was obtained by calling mSupplier.get in a context where it can afford to block because it's using the ManageBlocker mechanism. So now let's go ahead and take a look and see how this could actually be used in practice. So if you go once again to the EX20 folder that's in my GitHub repository, you'll see that there's a little example that downloads a bunch of images given URLs. And one of the methods that we use here is called blocking download. And we'll see what that does in a second. And basically the idea of this example is to use BlockingTas to ensure there are enough threads in the common fork join pool in order to be able to do these downloads efficiently. So let's take a look and see how this works. So blocking download takes a URL and returns an image by downloading it. And as you can see here, it does a call to blockingtas.callinManagedBlock. And what that does, as you can see, is it takes a Lambda expression, and that Lambda expression is going to go ahead and do whatever it needs to do. From the point of view of the blocking task callinManageBlock method, it doesn't know, it doesn't care. It just thinks of it as a supplier, so it can do whatever it needs to do. And in this case, the supplier is going to download the image at a given URL, which of course is likely to block, especially if it's a large image you're downloading. And by using this particular mechanism in the way we're doing here, the common fork join pool will automatically be expanded and contracted to handle the fact that the downloads could run for a while and therefore will block the calling thread. So this is a very nice, clean way of being able to use ManageBlocker without having to expose any details to the programmer about the ManageBlocker interface or the block method or the isReleasable method. All those things are encapsulated very cleanly within this API. As I mentioned before, any extra threads that are created in the common fork join pool will automatically be terminated later on, so you don't have to worry about managing that. Now, the one downside with this approach, and this isn't really a knock against the blocking task per se, it's a knock potentially against using ManageBlocker, is if you have a large number of requests that all come in a burst, then you could end up saturating the CPU by just allocating tons of threads. That's always a challenge. This approach, which adds new threads to the common fork join pool, is really not carefully designed to think much about that. The good news is that fork join pool and common fork join pool in particular has limits on the number of threads that you can allocate. And I think with newer versions of Java, it's some number like 64 threads or something like that. But you can take a look and see what the actual limit is. But the point is that this is a nice way of growing things without, if you don't have too many crazy requests coming in at the same time, it's a very convenient way of being able to expand the number of threads without having to worry about making your code inefficient and without having to worry about doing things like guessing ahead of time what the statically allocated number of threads in the pool should be. So that's the end of the overview of Java fork join pool's common thread pool and its use of ManageBlocker, and a nice way to encapsulate it within the blocking task wrapper class.